This is a follow-up video for my Yokomo YZ10 870C. Since the first video that I showed for this, I made a few changes, a few updates. I just wanted to try to fill you in on that now that it's basically a complete chassis. So the first thing I want to go over is the battery tray. Let's see if I can get some better lighting here. Okay, so when this chassis was made, and for that matter all of the other YZ10s, they were made assuming that you would run standard NiCads or nickel metal hydride cells. That's why this chassis is cut out like that at the bottom. Okay, so to put lipos in here, it's not too hard, but it's not entirely straightforward either. So for example, on this side, okay, let me just take this off. This is the right side of the chassis. You have 4 holes. On the left side, you have 3 holes. So a standard lipo cell, a saddle pack cell, will move around in here a lot. So you need to find a way to lock it down. So what I did is I had a spare B44 lipo tray, and I just sort of cut the carbon fiber from that into little bits and glued it to the chassis with shoe glue using my Lipo pack as a template, so I knew where to glue everything. Okay, and that seems to hold the battery in place just fine. The other thing is the Lipo packs that I use Turnigy 4850 milliamp hour packs. They're about the same size as a Reedy pack or an Orion pack, same general form factor. The height of that pack is a little too large for the body clip holes here in the standard Yokomo battery posts. So what you need to do is add a little nut or some spacers or something just to push the body post up. That way when you mount the battery in and you put the battery tray over it, the battery won't push the battery tray up and you can actually get the body clips in there. So these battery tray pieces here I made myself because when I got this chassis it didn't come with any battery tray mounts. So if you go on eBay, you can find carbon fiber sheets. So literally just type in carbon fiber sheet 2mm or 3mm or whatever, and you can get decent sized sheets. I think I got like a 1 foot by 1 foot or something for about $20, and you just cut it yourself. Just make sure when you cut carbon fiber, either these little bits here or this bit here, that you do it in a well ventilated area, because carbon fiber makes a lot of carbon dust. You don't want to breathe that stuff in. It's really nasty. So, do it outside or do it in a very well ventilated area. Okay, so let me just put that aside. The other thing I want to go over here is Droop. So when I got this chassis, some of the friends that I go racing with that have had more history than I do in RC, they commented that the 870C was very bad at jumping. And I tried to understand why, and they gave me a little bit of insight. And basically the problem, as I was able to interpret it, was that the suspension arms did not get enough droop, which means that basically the ride height couldn't be high enough when you're landing or when you're going off a jump. So first I'll show you what I did to the rear and the front to obtain that. So if we go to the rear, it's a very simple fix. If you're willing to do this to your chassis, let me see if I can just flip this over here. Okay, right here. So if you let the rear suspension arm run freely, what you'll find is that the rear of the rear arm is the first part of the arm to run into the lower chassis plate, and it runs into it at this back corner here. So all you really have to do is take a Dremel and cut out a little square here at the back corner, and that will allow the rear arm to run a little further down, so you get a lot more droop, which means if you want more ride height, you can get more ride height. But droop isn't just for ride height, it's also for when you're, it's for a few things. When you're in the air, the suspension arms are all the way down, which means that when the car lands, you have that much more suspension travel to absorb the energy from the jump, from the landing. Okay, so more droop will help the car land better without bottoming out, slapping the chassis against the ground. Okay, so that's one area where it helps. Also, if you want the car to dive more under braking, then you'd want, say, a bit more droop in the rear to allow the rear to lift up more. But that's not as important, at least for this chassis, as the jumping performance, at least as far as I've been told. Now for the front, getting more droop is a little trickier because it's not just one little spot in the chassis that's limiting the front suspension arm movement. It's actually two things. So if you look closely at the front arms and how they move and what they're running up against as you press them down, there is a spot toward the rear of the front arm that does run up against the chassis. Let me see if I can, basically right about here. Now you don't have to cut out a square. You can actually just take a Dremel sanding bit or a grinding bit and just sort of shave away at the toward the top of the chassis down, try to make a more beveled or angled cut there. That'll allow the arm to droop down a little more. The other thing is actually the magnesium front bulkhead. At least for these arms, I can't really speak for the stock arms, but at least for these arms, basically what's happening, okay, maybe it's hard to get a great view here. So this little rectangular piece here, the front edge there that my finger's running across right there, the arm at full droop is sort of scraping against that. So to address that, you take that edge, you take a sanding bit or a grinding bit, and you just grind away at that edge a little bit just to make some more space for the front arm to move further down along the front bulkhead before running into anything. Now, in doing this shaving, you will create magnesium dust. I don't know what the safety hazards are for that. Just make sure anytime you create dust, make sure you don't breathe it in. But you will be generating quite a bit of magnesium dust here. So at least for the sake of keeping everything clean, you might want to just remove the front bulkhead and do that, or maybe try to cover everything up here before shaving the front of the bulkhead, because it will get dust over like your diff out drives and everything, and it'll just take some effort to clean that off. But having done that, I can say that certainly for the front, I get about a quarter inch or so more droop than what it was in stock form. Okay, so this should help a lot presumably for jumping performance. Now, why do you want droop in the front? Well, as you're approaching a jump and you're accelerating up the incline of the jump, the front end is going to lift. Now, if the front end is not lifting, or if it's not lifting as much, it might slap into the top of the jump, or the car itself, just as it's going in the air, it might not rise as much in the front, which means in the worst case, it'll actually dive forward on landing. And I've had that problem before in my 4x4 short course truck. Thankfully, that truck has enough droop, and all I had to do was just put stiffer springs on the front to push the arms down and push the front up. So in this case here, having more droop will help the front lift a little more as you're going off jumps. Okay. So I think that's it. I just wanted to go over the lipo tray conversion here and the modification to the chassis to get a bit more droop, hopefully better jumping performance. And that's it. Thanks for watching.